hydrograph analysis. Here, next topic we are going to discuss about unit hydrograph. Before going to discuss about unit hydrograph, we should know what is hydrograph. Hydrograph is the graph represents time versus discharge. Here, first of all, you know what is discharge, what is flood discharge, what is flood hydrograph. Then we are going to discuss about hydrograph analysis. Here, rainfall is different from flood discharge. If the rainfall duration is 3 hours, but the flood duration is not 3 hours, that should be more than 3 hours. It depends upon the intensity of rainfall. So that the flood duration should be more than the rainfall duration. For example, if we are moving in a one street, if the rainfall occurring on a particular area, so we are going to take rest in some shed. The rainfall is falling on a particular area 1 hour continuously. If the rainfall ends, then we are going to move in our path. Even though after ending the rainfall, we are having some flood in that street. That is nothing but flood. Right? Here, hydrograph is the graph between the discharge or flood versus time. Here, horizontal axis we are going to take the time. This is the discharge or flood. This graph is nothing but hydrograph. Here, having different hydrographs. For example, the rainfall falling on a particular area 3 hours and giving gap 1 hour and again start rainfall, have different hydrograph and different hydrographs. Here this hydrograph, this is one hydrograph, this is one hydrograph, this is another hydrograph. Right? Here what are the component parts of the hydrograph? Here, so once you see the figure, here, this is the hydrograph. This is one hydrograph, single peaked storm hydrograph. Earlier we are having another hydrograph like this because this is another storm hydrograph, another rainfall duration hydrograph. Here this is the raising limb, this is the raising limb, this is the resection limb. Resection limb, this is the raising limb. Here this is one hydrograph here based on the earlier storm. So this is the resection limb of the earlier storm. So here you should learn some points here. This is the peak of the hydrograph. D is the peak of the hydrograph. A is the point of raise of the hydrograph. Point of raise of the hydrograph. Right? Here we know already discussed about that what are the types of runoffs. So we have discussed many types. The runoff is classified into different ways. That are the surface runoff, interflow and base flow. These three are the main classifications of runoff. Now, surface runoff and subsurface runoff are land flow and subsurface runoff. Our land flow and interflow is combined together is known as direct runoff. And another one is the groundwater flow. Earlier we discussed 3 ways, 3 types: surface, subsurface and groundwater flow. Now surface and subsurface together treated as a direct runoff, then remaining one is the groundwater flow. Here we know what is direct runoff is the combination of surface runoff and subsurface runoff is nothing but the direct runoff. How to separate the direct runoff from the groundwater flow? This is also one of the important parameters for the analysis of unit hydrograph. Yes, how to separate the base flow? How to separate the base flow from the direct runoff? This is the procedure. First, extend the resection of the flow existing prior to the storm to a point under the peak of the hydrograph line AB. Here you see the diagram here. This is the point A. This is the resection limb of the earlier storm. Right? This can be extended like this up to this one. This is the line extended from peak hydrograph. This is the peak hydrograph extended line. So this A should be extended up to this one, right? Point B here, located point B, AB is one line, and this line can be extended up to n days after the peak, this is the peak discharge, you know, hydrograph peak discharge here, n days after the peak. So the n days is determined by using this formula, n equal to 0.84 a power 0.2. This is the n days after the peak. This n days after the peak is also depends on duration of the rainfall as well as intensity of the rainfall. Here, based on this diagram, this is the n days after the peak. This is the point starting here. This is the n days after the peak. This is the line. Then join line B to this location. This is denoted as a C. So here the n days after the peak touches here. In some cases, this n days after the peak touches here. Definitely this line should passes like this. This line should passes like this. Or this n days after the peak moves up to like this. This is the point. Then this line moves like this. So this n days after the peak depends upon the intensity of the rainfall as well as duration of the rainfall. Then this line A, B, C, D is the direct runoff hydrograph or the total quantity of water above the ground surface. The line A, B, C separate the base flow. Below is the base flow, above is the direct runoff. Now we are going to draw one line here like this, one dotted line here. Here what is happening? The location A, here located some points A, B, C, D. Right here, the point from A to B is groundwater flow because the line below this line is groundwater flow. Yes. So the point A to B is the groundwater flow. B to C is the interflow or subsurface flow, and C to D is the surface flow. Here in our definition, the sum of interflow B to C and C to D, this is subsurface flow. The total depth is nothing but direct runoff. The B to A is the groundwater flow. Right here, this is the graphical representation. Apart from this separation of base flow from the direct runoff, here they have given one hydrograph here. Just now we discussed about this hydrograph. Here once you see the hydrograph, here they have used one infiltration curve here. This is not pi index. This is the Horton's equation curve. Here the infiltration rate is high, gradually reduces because the soil saturated condition, then reaches a limiting value here. This is this curve is nothing but hydrograph. So the below this line is nothing but infiltrated water, above water is nothing but runoff water. Right here, based on this hydrograph diagram, what you observe once you see the both, here this is the one period, this point to this point, and this point to this point another period, that is equal time interval. This point to this point another one, like this. Here only at the first location, for example this is 1 hour, and this is the another location, this is 1 hour. These two intensities are not giving any direct runoff. The total water entering into the soil. The remaining all periods, that are 1, 2, 3, 4, 5, 6, 7 hours of period gives the direct runoff. That means based on this diagram, the rainfall excess duration is 7 hours. 1, 2, 3, 4, 5, 6, 7 hours. Only the infiltrated time is 2 hours. Right here, apart from that, we are going to discuss about some definitions related to this hydrograph analysis. Here you see one diagram here, that is effective duration. So what is the definition of effective duration? Effective duration is the time between the rainfall intensity is more than the infiltration capacity of the soil. Here, for example, if the infiltration capacity of the soil is 10 mm per hour, the rainfall intensity is 8 mm per hour. So at that condition there is no runoff because the total quantity of water enters into the ground because the infiltration rainfall intensity is less than the infiltration capacity. Is it clear? Then what is happening? The effective duration means the rainfall intensity should be more than the infiltration capacity of the soil. That time is nothing but effective duration. For example, if the infiltration capacity of the 10 mm per hour, but rainfall intensity is 20 mm per hour, 15 mm per hour, 19 mm per hour, all these heads are the effective duration. Once you see the diagram here, this is the effective duration time. This point to this point, the rainfall intensity is more than the infiltration capacity of the soil. Therefore, this is the effective duration. Right? Another definition, that is the basin lag. It is the time between the centroid of the net rainfall and the peak of the hydrograph. You know, this is the peak of the hydrograph. This is the centroid of the net rainfall. The between these two duration is nothing but basin lag. And resection time, this is also very important definition. Resection time means it is the duration of the direct runoff after the end of the effective rainfall. You know, we have some effective rainfall. For example, we are having 10 hours rainfall duration. The duration of the rainfall is 10 hours. Out of 10 hours duration, 3 hours rainfall intensity is infiltrates down. Only we are having 7 hours rainfall that is available as a runoff, that is the effective rainfall. After end of that 7 hours, 7 plus 3, 10 hours, even though some quantity of water flows above the ground surface up to certain time, that direct runoff is known as the duration of that direct runoff is known as resection time. That means after end of the effective rainfall, after end of the effective duration, even though the water flows above the ground surface, that duration, the direct runoff duration is known as resection time. And time of concentration, this is also very important definition in case of hydrograph analysis. So here, for example, this entire board is the one catchment area. The entire board is one catchment area, that is catchment area of one stream. Stream is flowing at the bottom of the board. Stream is flowing at the bottom of the board. Here the rainfall falling in particular catchment area at a intensity or at different duration. The intensity of rainfall is 1 mm per hour, the duration is 10 hours on a particular catchment area. So in this case, the water falling on that catchment area, that water should reaches the stream. Here, time of concentration means the water far away from that location. This is the stream location. This is the stream. This is the far away from the particular stream. The water drop from this point to this point takes some time. That time is known as the time of concentration. That means the furthest point from the catchment, the water reaches from the furthest point of the catchment to the stream gauge is known, that required time is known as time of concentration. Here next one, valley storage. Right here valley storage means, so if there is no rainfall on a particular area, having one stream flowing in a particular area, but even though there is no rainfall, also the stream having some quantity of water flowing in the stream. Right? If there is no rainfall, also stream having some quantity of water. For example, the catchment area of that particular stream having some rainfall, that is 10 centimeters depth of rainfall for a duration of 10 hours. So at that situation, what is happening? The water, this rainfall is falling on a catchment of that stream, basin of that stream, so that that water entering into that stream, the water level should be gradually raises. Initially flowing some depth of water, that water level should be raises because of the water entering into that stream. The level should be raises up to certain level because of that flood. The level difference between the earlier level and the because of the flood water level is known as the valley storage of that stream. Right? This is also, this stream of water, this valley storage is not permanent one. This is just temporarily stored, temporarily moving on the stream after end of the rainfall. That water stopped from the catchment area, then some period of time that flows in the stream, then again reaches to the earlier level. This is known as valley storage, and another one is the channel storage. This is also part of the valley storage, but once the water enters into that stream, that flows in the stream in such a whatever quantity of water entering into that stream, that level should be flows, but some quantity of water flows above the bunds, top of the bunds, because of the floods is too high. The inflows into that stream is automatically increases. Once the floods high, inflows into increases, the water capacity, the capacity of the stream not having that much of capacity, automatically the water will flows above the bunds of the stream. So at that condition, the water stored within the bunds of the stream flows within the bunds of the stream. That stream of water is known as channel storage. So base flow or depletion curve here. So here once you observe this diagram, here this is the water level in the stream. This is the water level in the stream. In this condition, what is happening? This is the ground. This is the ground. So here the groundwater try to entering into the stream. If there is no floods, the water level is too low in the stream. In that situation, the water from the ground or water from the aquifer try to entering into the stream. Then having some rainfall on a particular area, on a particular catchment of that stream, the water joins into the stream. The water level may be raises from this level to this level. The water may be raises from this level to this level. In this case, what is happening? The water in the stream try to move into the aquifer, try to move into the this soil. That means the water level will be raises from this level to this level. So earlier this is the groundwater level, this is the groundwater table. That means that is the base flow. If we are having rainfall on a particular catchment area, flows entering into the stream, the water may be raises from this point to this point. In this case, this is the groundwater table, because the groundwater table not stable one. This is fluctuation one, up and downs. Then come to here. So already we discussed in the earlier diagram. A, B, C is the base flow line, that is the constructed base flow line or assumed base flow line. But strictly speaking, actually the actual that groundwater flow is, this is the actual groundwater flow. Right? If this is raises and fall down and raises, fall down. But this is the actual groundwater flow of that particular location.